Hi, so this time we will be working on some application problems that involve solving systems by substitution. All right, so here's our sample problem. A snack bar sells two sizes of snack packs. Large snack is $5, small snack pack is $3. So in one day, the snack bar sold 60 snack packs, and the total cost all of it is $220. So how many small snack packs did the snack bar sell? All right. So first things first, we need to set up our equations. Now remember, we need two equations because we're talking about systems. All right. Now, one tip that I can give you is that whenever you are dealing with selling or buying and things like that, typically you can set up your equations by thinking of two things. All right. Equation number one, okay. Equation 1 is about the number of items. Okay, so in our case, how many were the items sold? How many snack packs were sold all in all? And then usually your second equation is going to be the total amount. Okay, the cost. All right, that's what you will be working on. Okay, so let's have our first equation. How many total items were sold all in all? As you can see, the snack bar was able to sell 60 snack packs. So our first equation will be, now remember, we have two kinds of snack packs, the large and the small. So that could already represent our X and Y. It's up to you which one you want to use for your variables, okay? So just to be consistent, since large snack pack were mentioned first, so this is our X, and so our small will be our Y, all right? So we know that the number of large snack packs and the number of small snack packs that were sold, it will be equal to 60, all right? Now, how about the total cost? Now remember, your total cost would be the number of items times the price. It's always like that. So in our case, since the large snack pack is $5, so we can represent it as 5x. We add the total number of total number of small snack pack, and each snack pack is by 3, so that's going to be 3y. And how much was the total amount all in all? It was mentioned to be 220. So here's our systems of equations now, and so we can proceed with our process. As you can see, none of them has an x equals or a y equals, so we have to determine which will be the equation that we will use for substituting. And in this case, x and y on the first equation here both has no numerical coefficient right in front of them, so we can use whichever. All right, now typically since the question here is asking how many small snack packs, so as you can see, our small snack packs is y, so we will just use y to be by itself. All right, so this equation, we will rewrite it to become y is equal to, so x will have to go to the other side, so minus x plus 60. All right, so we will use this equation. So let's have this here. Hold on, I'm sorry. So we will have 5x plus 3. The y will now become negative x plus 60. Okay, that's what we have. Is equal to 220. So solving this expression, always check distributive property and then combining like terms. So this is going to be 5x minus 3x plus 180 is equal to 220. You can combine 5x and negative 3x. That's going to be 2x plus 180 is equal to 220. Okay. Now we can transfer the 180 to this other side. So we will have 2x is equal to 40. And so if we divide by 2, x is equal to 20. Now remember, what is our what is our x? X is the large snack. So there are 20 large snacks that were sold, but the main question was asking about the small snack packs. So we can have y is equal to negative 20 plus 60, and that is going to be 40. So 40 small snack packs were sold by the snack bar. Make sense? All right. So let's see our next example. All right. So pretty much the same idea. Go try this one out on your own. So it's pretty much the same as the previous example. So you have the number of games rented, x plus y equals 6. Total cost, it will be 4x plus 2y is equal to 22. Solving for one of the variables, so you can use the first equation. We can set it up as y is equal to negative x plus 6. Do your substitution. You will see that there are 5 new games that were rented and only 1 old game that was rented for this problem. All right. So, do we always have solutions? We've already tackled that when we talked about graphing systems. Now, how do we know if we have no solution or many solutions when we have substitution? Okay, so let me show you how it's gonna work. Okay, so just like what we do, we will substitute one of our variables. So in this case, this x here will be substituted by this expression. All right, so we will have, oops, sorry, my bad. So this will be 3.5 times negative 2y plus 4 plus 7y is equal to 14. All right, and so we will be distributing our values. So this will be negative 7y, and then plus 3.5 times 4, that's going to be 14, plus 7y is equal to 14. Now, as you can see, when we combine like terms, negative 7y and positive 7y, that's going to cancel, okay? And so we are just left with 14 is equal to 14. No more variables to be solved. We have an expression. So my question is 14 equal to 14? Yes, okay? Because this is true, then you have infinite solutions. Okay, so when all of your variables get canceled out and you are left with a statement, is it true or false? If it's true, then you have infinite solutions. All right, so let's take a look at our second example. So as you can see here, we can replace our y. We can replace this y over here. Okay, so that would be 3x minus 11 minus 3x is equal to negative 13. Combining like terms, you'll have 3x and minus 3x. So you'll end up with a negative 11. Is that equal to negative 13? It is not. So because it's a false expression, then there is no solution for this. Oops, sorry. I did not mean to do that. Okay. So if the statement ends up to be true, infinite solution. If they are false, it's no solution. All right. So to summarize, systems of equations can be solved in more than one way. We did graphing. This one, we are able to use substitution. So that is when you have an equation wherein the variable is by itself. That's when you can use your substitution method. All right.